If you've ever tried to grow anything, whether it's a little plant on your windowsill or a massive 1,000-acre farm, you've faced the same question. You're just staring at the dirt, wondering, what's the secret here? What does this soil need to give me the absolute best harvest? For literally centuries, that question has been a total guessing game.
And that guessing game is what I like to call the Goldilocks problem of farming. See, if you add too little fertilizer, your crops are going to starve. But if you add too much, well, you've just created a whole different kind of mess. The real trick is finding that sweet spot, the amount that's just right.
And believe me, the stakes for getting this wrong are incredibly high. On one hand, you use too little fertilizer, you're leaving money on the table. You're getting smaller yields, which means less food and less profit. But on the other hand, if you use too much, you're not just throwing money away on chemicals the plants can't even use. You're actually polluting the environment as all that extra stuff runs off into our rivers and streams.
So how do we get past all this guesswork? Well, the answer comes from science, with an approach that basically gives a prescription for the soil. And this is where we get to introduce a concept called soil test crop response, or STCR for short.
Think about it like this. A doctor would never just hand you a prescription without running some tests first, right? Of course not. STCR applies that exact same logic to farming. It's a method that uses a quick chemical analysis of the soil, that's the test, to create a super precise, numbers-based fertilizer recommendation, that's the prescription. And it's all tailored for a specific crop, so you can get the best results possible.
And this isn't just about a one-off test for a single field. Oh no, the goals here are much, much bigger. This SDCR approach, it's about building a huge scientific database that connects soil health directly to crop yields. It's about creating these really precise mathematical equations to hit specific harvest targets. And by using fertilizer so much more efficiently, we can actually reduce the total amount we need. It's all about building a reliable scientific foundation for farming advice.
Okay, so how does this whole philosophy actually work in practice? What's the core idea driving it? Well, it all comes down to something called the targeted yield approach.
The principle behind it is beautifully simple. For a plant to grow and produce a certain amount of corn, or fruit, or whatever it is, it has to take in a very specific, measurable amount of nutrients. Nitrogen, phosphorus, all that good stuff. It's just basic chemistry, really. If you know how much you want to harvest, you can figure out exactly what that plant needs to eat to get there. So, the whole process breaks down into 4 pretty simple steps. First, the farmer sets a realistic goal for their crop yield. Second, you test the soil to see what nutrients the field already has. Third, and this is the key part, you do the math. You calculate the gap between what the crop needs for that target and what the soil can already provide. And finally, you get a precise fertilizer formula designed to do just one thing: fill that exact nutrient gap. No more and no less.
So that's the science. But what does it actually look like here in the 21st century? Well, this is where SCTROPH hooks up with the incredible technology of what we call precision agriculture.
See, back in the day, soil sampling was a pretty broad strokes kind of thing. You might take a few samples to represent a huge area, maybe 20 acres or even more. But today, with precision grid sampling, the whole process is way more intense. Instead of treating a whole field like it's one uniform thing, we can now analyze it like a complex mosaic full of different zones that each have their own unique needs.
And the goal of all this intense sampling is to create a digital map of what the field needs, what's called an application map. So don't think of it as just a report. It's more like an actionable digital blueprint of your field's fertility.
This workflow is where it all comes together, and it's seriously cool. So that sampling data creates the digital application map. That map gets loaded directly into a computer on a high-tech fertilizer spreader. And as that machine drives across the field, it uses GPS to know exactly where it is, and it automatically adjusts in real time how much fertilizer it's applying to match the specific needs of every little zone on that map. It's practically surgical.
This technology is just incredible. But why should it matter to anyone who's not a farmer? Well, because this is about the future of how we feed ourselves.
When you really zoom out, the benefits are just enormous. For the farmer, yeah, it means bigger yields and more profit while cutting way down on wasted fertilizer. For the environment, it means a huge reduction in chemical runoff that pollutes our ecosystems. But for all of us, this is a critical tool for global food security. It means we have a more sustainable and incredibly efficient way to produce the food we all depend on.
So, the next time you see a field of crops, just think about the incredible science that could be happening right there, just beneath the surface. And I'll leave you with this final thought.
What if every single farm on Earth could grow more food with less waste? What would that really mean for our world?